Alright, good day everyone. So welcome back to my YouTube channel, and today we will be talking about washer method. So this method is useful when the axis of rotation is not a part of boundary of the plane area. So like this, so it does not touch to the axis of rotation. If the axis of rotation is the axis, the upper boundary of the plane is given by y is equal to function, the lower boundary by y is equal to g of x, and the region runs from A to B. So the volume B of the solid of revolution is given by the volume is equal to pi y squared sub 2 minus y squared sub 1 dx from C to from A to B rather from A to B. Okay, so we're going to think of this that when the axis of rotation is this one is along the x-axis, so therefore we need to get the length of the strip as our distance here, the distance or the length of the strips. So considering this one, this is upper minus the lower. So therefore, we are going to get the upper minus the lower here, and our dx, since this is in terms, the axis of rotation is perpendicular to these strips. So therefore, we can say that the change of this is the width is our dx. So by the upper and the lower boundary, because the axis of rotation is along the x-axis. Okay, so y squared minus 2, y squared sub 2 minus y squared sub 1 dx from A to B. So how to determine what is the functions or the functions of it, the in terms of x or in terms of y. Okay, so if the axis of rotation is the y-axis and the plane is bounded to the right by x is equal to fy, to the left by x g of y, above y is equal to d, and the below is c, then the volume is given by this one. So here, v is equal to pi from c to d. And we have to get the length of our strips, which is from right minus the left. So right here is x sub 2 and the left is x sub 1. Then we're going to square, and of course the axis of rotation is along the y-axis, so therefore that is in terms of dy. So that's in terms of dy as our width here. So again, this is still perpendicular to the y-axis. So this strips is perpendicular to the y-axis from C to D as our boundary. So let's have problem number 1. So find the volume generated by revolving about the x-axis in the area bounded by the curves y is equal to 2x and y is equal to x squared. The first thing that we're going to do here is we need to find the point of intersection. So by given y is equal to 2x and y is equal to x squared, y is equal to 2x, and we have the value. So y is equal to 2x and y is equal to x squared by comparison. So y is equal to x squared. And this one, what is the value for y here and what is the value by comparison? 2x is equal to x squared. So by factoring, so x is equal to 0 and x minus 2 is equal to 0 and x is equal to 2. When x is equal to 0, the value for y is 0. So here is the point of intersection. When x is equal to 2, the value for rx is equal to 2 and the point of intersection is 2, 4. Since the axis of rotations here or revolutions here is about the x-axis, rotation is about the x-axis, so we know already that the functions that we are going to integrate is in terms of x. So here, this is the formula here. V, since the axis is about the x-axis, so this is the formula that is fitting to this one, to this problem. So pi is equal to pi times y sub 2 squared minus y sub 2 y squared sub 1 dx from A to B. The first thing that we're going to do is we need to find the length of our strips. So the length of our strips here, the distance from here, y sub 2, there's upper minus the lower curve. So this is the upper curve here and the lower curve here. So this is the upper because this is upper and the lower, above or the lower curve here. Highest and lowest curve. This is the highest and this is the lowest curve, or above or below. And this one, this is y sub 2, y sub y squared sub 2 minus y squared sub 1 here. And that is the width is in terms of dx. So how to get the boundary? Since that is in terms of dx, because the axis of rotation is along about the x-axis. So therefore, from here, what is the intersection? In terms of x, this is 0. And going here, this is 2. So therefore, from 0 to 2. Then substitute the value for y. Our value for y is equal to 2x here. And our y sub 2, because this is our upper. Alright, this is our upper, which is the value for this one. This function is y is equal to 2x. And the lower function is y is equal to x squared. Then squared. All is squared here and squared. So therefore this is 4x squared minus x raised to 4. And in terms of x, that is dx. And the bound is from 0 to 2. So that's 0 to 2. Then we need to integrate now. This is 4x squared. The result is 4x cubed over 3 minus x raised to 5, the basic integration formula. So from 0 to 2, because the boundary in terms of x is from 0. This is 0, the intersection, because all of this one, we need to get the revolution of this one. The area or the volume here rotating. So pi is equal to 4x cubed over 3. Then substitute the value for 2 here. And 2, and this will become 0. So therefore, if we're going to use the calculator, we need to compute this one. That is equal to, v is equal to 64 pi over 15 cubic units. So that's it for, that is the axis of rotation is along the x-axis. So next, proceed. Find the value of generated by revolving about the y-axis and the area bounded by the curves y is equal to x squared and y is equal to x. So find the volume of the generated by revolving about the y-axis. And the area bounded by the curves y is equal to x squared and y is equal to x. So since the axis of rotation is about the y-axis, so this, we need to get the distance from left to right, and this is in terms of y. So the first thing that we're going to do is we need to get the intersection. So intersection is y is equal to x and y is equal to x squared by comparison. So x is equal to x squared. So factor this one, x squared minus x is equal to 0, and x times x minus 1 is equal to 0. So we need to, here, x squared minus x is equal to 0. So we have to transpose this one. It becomes x squared minus x is equal to 0. And factor x is equal to 0. Because if we're going to have this one, x is equal to 0 here. And this becomes x is equal to 1. So when the value of x is equal to 0, y is equal to 0. That's the point of origin. And when x is equal to 1, y is equal to 1. So therefore, this is the intersection between this one. So this is the right, okay, this is the right curve and this is the left curve. Because we need to get the distance or the length of the strips. To get the length of the strip that is perpendicular to the y-axis of rotation. Okay, when it is perpendicular to the axis of rotation, we know already that the functions that we're going to integrate is in terms of y. And next is that this is in terms of y, since the dy here, they were going to take the width of this one. So from the boundary is from 0 to here. This is our y, right? This is y. 0 and a 1 and a 0 and 1. So this is the boundary. So it is the point of intersection. Are all the y here? 0 to 1. So what is the value for our x? The value for our x here. So if the value for our x in this right here, this is right minus the left, right minus the left. So right here, since this is in terms of y, so we need to transform this one into y is equal to x squared. So square root, so y is square root of y is equal to x. So the value for our x is square root of y, then quantity squared, because the formula has a square. Minus, this is the left. This is the left function. So y then squared. So just simply substitute because x is equal to y. Then dy. Then squared here, this become y, and this become y squared. And the bound is from 0 to 1 dy. Then integrate y squared over 2, then y cubed over 3 from 0 to 1. So substitute the value for our y, which is 1, and this will become 0 because this is substituted by 0. So the answer, if we're going to use the calculator, v is equal to pi over 6 cubic units. So that's it for the washer method. So thank you so much for listening.